Hi, and welcome to the Q&A series with Fixitgearware Security. Today marks it the 9th episode since we started the Q&A series, and it's been a journey so far as we have dived into various questions that spans across various topics in cybersecurity. The goal of this series still remains the same, is to teach you how to break down cybersecurity questions into simpler forms and understanding how the questions being asked are to be answered. When it comes to cybersecurity, nobody's perfect, nobody knows it all, and every day the industry keeps changing with new technologies, new topics being introduced, and software applications as well regarding AI as well, and other topics regarding the profession. So as the industry keeps changing, so does the scope of things to learn keeps increasing, and oftentimes users find themselves coming across various technical questions on the internet. Most of these questions have answers which are accurate, most do not, and even at that, the questions are not properly explained or summarized why the specific question has that particular answer. So it's a challenge, and at Fixitgearware Security we saw this and we took the initiative to start the Q&A series. So whatever question we talk about in the series, we would summarize the definitions of the various options given. Then we'll now crack down the specific answer that fits into that particular question. So by so doing, users would have the answers and also understand why that particular answer is the perfect choice for the question being asked. So we hope so far we have been improving, and those who are watching the videos also, we thank you for showing us your little support. Do not forget to also share with your friends to also watch and subscribe to the channel and also be able to break down these questions. And it's not just about knowledge. Also, we believe others who are preparing for professional certifications would also come across questions, not just exactly how we asked it, but similar to the questions we do present on the various episodes of the Q&A. So when users come across these questions on their professional exams such as CH, the Certified Ethical Hacker examinations, they'll be able to confidently answer these questions because they have come across the definitions of terms being supplied in these various questions, maybe from our channel or from other reliable sources on the internet they have been using to practice for the exams. So on this week's episode, we'll be featuring questions ranging from penetration testing, DevSecOps, nmap scanning, SAST procedures, and more. So by the time you're done with today's episode, you should be able to understand the various answers to the questions being asked today or being presented in the episode. And by so doing, also include the information to your archive of knowledge and information that you know about cybersecurity. So without further ado, let's get started. Question number 1. As a penetration tester, which of the following best describes the benefits of automation testing? Option A, we have provides accurate results. Option B, speeds up time and process. Option C, more tests are covered. Option D, A, B, and C. Option E, none of the above. Option F, all of the above. Now let's understand what automation testing is all about. So automation testing is the process by which automated tools are used in conducting vulnerability assessment of a web application, server, and mobile application. Automation testing speeds up time and process, enabling the tester to cover a wide range of tests. However, there might be issues of false positives due to the pre-configured mechanism known as payloads in the tool. So having defined what automation testing is all about, let's visit the question once more again. Now from the question, we have one keyword highlighted. We're asked which of the following best. So focus on the word best and also automation testing. Now for option A, provides accurate results, and this is false in the sense that using automation tools is dependent on the predefined payload by that tool. So for example, let's say you're using a payload to test for SQL injection, but your payload contains a series of strings or characters that has been filtered at the back end of the database. So when you try to inject those payloads, they do not work anymore. You might end up having that the database is not vulnerable to SQL injection, right? However, this is based on the list of payloads supplied. There might have been modern payloads discovered by security researchers where you can manipulate a few strings into an injected payload and be able to obtain an SQL injection in a database. But due to you not having that payload, you might end up having a false negative. So what is false negative? Definitely it means that the database is still vulnerable to SQL injection, but your lack of having the accurate payload or strings that can be able to manipulate that database to have an SQL injection error makes it to be a way that the tool will not be able to discover any vulnerabilities. So you might end up, after conducting your automation testing, you might end up not discovering a vulnerability. There is a vulnerability. So when a hacker who is well experienced and has a list of payloads in his hands, and in that payload he has the specific payload that can trigger an SQL injection in the database of the web application, they can be able to manipulate the database. And it's also a bad tell on the organization as well and its security research team, in the sense that it shows that they do not have a broader team that does accurate security research. So this is one of the downsides of automation tools. It's like feeding a robot an instruction and expect it to perform like a human. So the robot would always behave based on the instruction you've supplied, not based on what it knows. But a human, on the other hand, would think of various perspectives, source various information on how certain troubles can be, manipulated. So option A is out of the line or out of the result, is wrong. Option B is speeds up time and process. Yes, accurately true. One of the benefits is that it speeds up time, as you can see from the definition. So option B is correct. Option C, more tests are covered. Yes, option C is correct, because when you speed up time, right, you can be able to perform auto penetration testing using automation tools. So B and C is correct. Option D, A, B, and C is wrong, because option A is downrightly wrong from the definitions we've had so far and the explanation we've given. Option E, none of the above, is wrong. Option F, all of the above. So the accurate answer to question number 1 is B and C. Moving on to question number 2. Question number 2. Which of the following is not true about DevSecOps? A, security should be an afterthought. B, security should be included in the entire SDLC. C, it fosters collaboration amongst teams. D, B and C. E, none of the above. F, all of the above. So let's define DevSecOps to know what is the accurate answer for this question. DevSecOps is a part of cybersecurity, which promotes the importance of security as part of the SDLC. It is of the philosophy that security shouldn't be an afterthought, but rather be a part of the SDLC. One of the benefits of DevSecOps is that it fosters collaboration among team members. Dev, security, and operations. So Dev here stands for development, Sec also here stands for security, and Ops here stands for operation. So going back to the question, the keyword here is that it's not true. And option A says security should be an afterthought in DevSecOps, but from the definition it says no, security should not be an afterthought, but rather included in the SDLC of the development of the software application. So option A is wrong. B, security should be included in the entire SDLC. True. Option B is correct. And C, it fosters collaboration amongst team members. And also C is correct because towards the ending of the definition, we saw that both the development, security, and operations teams are able to collaborate with their ideas on how to build and improve and secure the software application. So we were asked which of the option is not true. So the accurate answer to this question is option A. Security should be an afterthought is wrong. The SDLC stands for Software Development Lifecycle. To read more about SDLC, you can visit the link in this article. There is an article published on Fixitgearware.com about DevSecOps. Moving on to question number 3. Question number 3. nmap is a tool known by all cybersecurity professionals. Which of the nmap scan is IP fragmentation ID sequence algorithm based? Option A, the connect scan. Option B, the stealth scan. Option C, the idle scan. Option D, A and C. Option E, none of the above. Option F, all of the above. To be able to have the accurate answer to this question, let's define the various types of scan in nmap. The connect scan. The TCP connect scan or connect scan in nmap establishes a complete connection to the target using a complete TCP three-way handshake. The stealth scan, on the other hand, known as the SYN stealth, it establishes up to half of its connection with the target. The idle scan. The nmap idle scan is based on the IP fragmentation ID algorithm. It first tests the zombie IP ID generation by sending 6 synchronous and acknowledgement packets and analyzes the response or feedback. Going back to the question number 3, we were asked which of the nmap scan is IP fragmentation ID sequence algorithm based, and also that's the key word here, IP fragmentation ID sequence algorithm based. So moving down to the definitions given, the accurate answer to this question is the idle scan, because the idle scan tests the zombie IP ID generation by sending 6 synchronous and acknowledgement packets and analyzes the responses or feedback gotten. So the correct answer to question number 3 is idle scan. To read more about the idle scan, kindly visit the link in this video presentation. Moving on to question number 4. Question number 4. Which of the following is not a penetration testing tool? Option A, we have the dumpster diving. Option B, we have the debburster. Option C, we have the SQL map. Option D, we have the A and B. Option E, none of the above. Option F, all of the above. To be able to answer this question accurately, let's define the various options given. Dumpster diving is a process of searching refuse and dumpsters to obtain shredded documents, damaged drives, and other components improperly disposed that contains informations which can be used to target an organization. It is considered a recognizance phase and not a tool. Debburster, on the other hand, is a multi-thread Java-based tool found in Kali Linux that is used in brute forcing directories and file names on a web server or application. SQL Map is an open source automated tool that is used to execute arbitrary SQL injection commands on a web application that is vulnerable to SQL injection parameters. So having defined these three options so far, the accurate answer to this question is option A, because from question number 4, we were asked which of the following is not a penetration testing tool. So tool, we are considering tools that you can use to hack, not really the process or a phase. So B is correct, C is correct, but A is wrong, and the question asks us not. So they're asking us for the negative or which of the options that is not accurate, and that leaves us with option A, dumpster diving. Moving on to question number 5. Question number 5. SAST and DAST are one of the DevSecOps testing procedures. Which of the following best describes SAST procedures? A, SQL injection. B, brute force attack. C, cross-site request forgery. D, source code review. E, none of the above. F, all of the above. To be able to understand this question, let's have a short description or definition of what SAST is all about. So SAST is a security testing procedure which analyzes a program, source code, or binary files to detect what part of the code is vulnerable without executing the program that is being reviewed. Having defined what SAST is all about, let's head back to question number 5. The key word here says best describes SAST procedures. So SAST is also considered a white box testing in the sense that the software tester or the application tester has the source code of this application being tested. So they have the raw file or the software itself. So when you consider the definition of SAST or the procedures of SAST, you're generally reviewing the source code of the application to look for what part of the source code is vulnerable to SQL injection, brute force attack, XXS, CSRF, LEADAP, or other forms of OWASP vulnerabilities that might exist in the application. So having defined what SAST is all about and understanding an overview of what is the process of SAST, option A is wrong because it's not the best description of SAST. Option B is also wrong, it's not the best description of SAST. Option C is also wrong, it's not the best description of SAST. Option D is correct because SAST involves source code review. Option E is wrong and option F is also wrong. So the accurate answer to this question number 5 is option D, source code review. SAST is also known as static application security testing. So basically, as we previously defined, you're testing the source code itself. It's not, the application is not yet, brought to life or set to the public to be used for the purpose which the application was designed or developed for. And the process of sending this application to the live or to the public internet is called putting the application into production. So when you hear the word, the technical term, that the application is in production, it means it's now live. Users can now use this application for whatever reasons the application was designed. Moving on to question number 6. Question number 6. During SaaS testing, one of the goals is to detect vulnerabilities that exist in the code. Which of the following is not a vulnerability detected during SaaS procedures? A. Sensitive information disclosure. B. Hard-coded credentials. C. Input and output validation. D. A and B. E. None of the above. F. All of the above. Going back to the question, we have two keywords here. The first keyword is not, and the second keyword detected during SaaS procedures. So an overview of these questions that we are being asked which of the vulnerabilities listed is not detected. So sensitive information disclosure is part of the vulnerabilities detected during SaaS testing to detect what part or component of the application is leaking information. It could be a part of the software that was written wrongly, that's a parameter that is being injected by a malicious hacker could reveal information about the application. It can be the technology stack. It could be also an exception catch that was wrongly, written, which would throw out exception errors to this user, and user can be able to understand what that particular or segment of the code is doing or performing. It could also be a part of the application that has to do with SQL injection. So maybe there's a part of the application that comprises of stored SQL queries, which if the user injects a malicious string, can be able to reveal what that segment of the code or how that part of the application connects to the SQL database. Option B, hard-coded credentials, is part of the vulnerabilities discovered. So if you're familiar with APIs and API calls or GraphQL, you can notice that various APIs talk to one another. And these APIs talk to themselves with what we call API secret keys and tokens. So API A can be calling API B if they establish a connection together, right? So most software applications are filled with this error whereby these sensitive keys or secret keys are hard-coded into the application during the development stage, and they were not corrected before the application was set into production. So when a hacker tried to obtain these API endpoints, they can be able to find a way to manipulate that API endpoint to reveal what we call the PII. These are called personal identifiable informations that the organizations might be handling using that various API calls. So hard-coded credentials is correct. Input and output validation is also an error. You don't want a situation whereby a user will supply a bunch of strings, also has to do with SQL injection as well. And instead of getting the accurate result, it's throwing an error. Then the user can be able, or the hacker in this case, if it's a malicious hacker, will be able to obtain what we call error-based SQL, right? Error-based SQL in the sense that it tells how the SQL or the back end of the application is handling the errors. And the users will be able to understand that, okay, if I can be seeing these errors, that means this particular endpoint is vulnerable to SQL injection. So moving back to question number 6, we were asked the keyword focus here is not. So of all the SaaS, of all the vulnerabilities detected during SaaS procedures, A, B, and C is correct. D, A, and B is wrong because A and B are also vulnerabilities detected. Option E is the correct answer to this question because it's none of the above. All answers are correct. and option F is also wrong. So the accurate answer to question number 6 is E, none of the above. Question number 7. To prevent SQL injection attacks, which of the following procedures should be implemented by a security expert? A. Principle of least privilege access to the database. B. Implementing parameterized queries. C. Store the SQL procedures. D. A and B. E. None of the above. F. All of the above. Going back to the question, the two keywords here are prevent SQL injection. Which of the following procedures should be implemented? So on the database end, the principle of least privilege access to database should be implemented is correct. B, implementing parameterized query is also correct in the sense that if certain parameters are injected, the software application or the endpoint where they were injected should be able to reject these queries and refuse them to be executed. C, store the SQL procedures. This is actually wrong because if you store the SQL procedures, the ethical hacker will be able to understand how the database connects to the various tables that is created or that is in the database. So storing the SQL procedures is a bad practice. Do not do that. If you're a software developer or if you're a cybersecurity expert that builds tools that provide a SaaS business model in the sense that your tool is a software as a service where users have to pay subscription, you do not want to use the principle of storing the SQL procedures on the back end of the applications, as this can be in a way queried and users can be able to understand the underlying code of how the application connects to the database. D, A and B. E, none of the above. F, all of the above. So question number 7 is talking about the following characteristics that should be implemented. So option A is correct. The principle of least privilege access to database should be implemented. Option B, implementing parameterized query is also correct. Option C is wrong. You do not store the SQL procedures, right? Option D, A and B is correct because option A is correct. Option B is correct. Option E, none of the above is wrong. Option F, all of the above is wrong. So the correct answer to this question number 7 is option D, A and B. The principle of least privilege and implementing parameterized query. Moving on to question number 8. Question number 8. What are the two distinct structures in DevSecOps? We have the PaaS and SaaS. We have the RAS and SAC. We have the IAC, known as the IAC, and the SAC. And we have the A and C. E, none of the above. F, all of the above. So let's define the various terms or acronyms given, such as PaaS, SaaS, RAS, SAC, and IAC. Platform as a service is a cloud-based computing model providing hardware, softwares, and infrastructures as a service. Example of PaaS is like AWS. AWS can allow you to use their platform to host your own software applications or containers, right? So they offer the PaaS or platform as a service kind of business model. The SaaS, software as a service, is a software-based distribution model that allows users to host their applications on their platform and make them available to their customers or end users on the public internet. So example of software as a service as well is Google Cloud, Microsoft Azure, and other platforms out there which offers the SaaS business model. The RAS, also known as ransomware as a service, is a cybercrime business model that enables threat actors to rent, purchase malware applications which are used for malicious purposes. Example of the ransomware as a service business model is the renting of botnet services. So if you go on the dark web, you would see where various platforms are advertising those who intend to perform malicious attack or sinister act to rent their service or their botnet service at a specific fee, and also including the Bitcoin or other forms of wallet addresses where the customer needs to make a payment to get the software which would be used to perform such, crime or carry out the botnet attack, which results into what we know as the DOS, which is the denial of service, or the DDoS, which is also known as the distributed denial of service attack. ISC, also known as infrastructure as code in DevSecOps, is responsible for the managing and resource provisioning in computer data centers, adopting machine-readable definition files, and not relying solely on interactive tools or manual configurations. So IAC or IAC is known as an automation procedures in DevSecOps. It doesn't rely on manual configurations, and solely it's an automation testing procedures. The SAC, known as security as code, is a concept in DevSecOps that involves the integration of automated security concepts directly into the entire software development process as part of the SDLC. So having defined these various options, the correct answer to question number 8 is option C, IAC or IAC and SAC or SAC. Moving on to question number 9. Question number 9. Cross-site scripting, also known as XSS, is a vulnerability that allows a malicious hacker inject malicious JavaScript codes into vulnerable web application. Which of the following is not a characteristics of stored cross-site scripting? A. The injected code executes on the web server. B. The injected code is stored on the web server. C. The injected code executes on the victim browser. D. The injected code slips the database of the compromised server. E. None of the above. F. All of the above. Going back to the question, the key word here is which of the following is not. Focus on the is not. Then characteristics of stored cross-site scripting. So here we're talking about cross-site scripting. The injected code executes on the web server. So we're not talking about RCE. RCE is known as remote code execution. When the malicious hacker injects a code, the code is executed on the back end or the server side of the application. So what happens is that for RCE, when you inject the code, the web server reads these codes and runs it, depending on what payload or what operating system or software the web server is running. So if the web server is running a Java software, right, and you inject an RCE Java payload, this web server will read this file and execute it. And I use the word spit out, not actually, reveal. Spits out the various information such as the version of the software it runs, the operating system. Then you can be able to assess the storage unit in terms of the local drives or the various storage files that the server is holding. So option A is out of this question because we're not talking about executing code on the web server, which is RCE. Option B, the injected code is stored on the web server. True. Option B is correct in the sense that for stored cross-site scripting, when a malicious hacker sends a JavaScript, this JavaScript is stored on the server or the web server of the web application. Usually the aim is that whenever a user visits the website, in this case a legitimate user, the JavaScript should trigger and perform whatever act which the JavaScript was designed to perform. It can be stealing of credentials, cookie sessions, and all the sensitive information which the legitimate user has supplied to that website or web application that was infected with a cross-site scripting script. So option B is correct. The injected code is stored on the web server. Option C, the injected code executes on the victim browser. Yes, option C is correct because when the user types on the browser, let's say for example, visit Fixitgearware.com, and we do not apply a very strong security mechanism or measure, and by so doing we became vulnerable to some weirdos injecting scripts into our website. The user can be easily infected. Whenever they visit, the script will trigger. But in this case, it's not possible because we have a strong security structure in our infrastructures or various applications we release to the public. So that's why it's good to be security conscious. And if you're not a security expert, employ the skills or services of a cybersecurity expert. In this case, you can consider Fixitgearware Security, who would provide various application testing to test where your application is vulnerable and informations that are being exposed or endpoints that can be manipulated to become vulnerable to these various security flaws such as the cross-site scripting. So option C is correct. Now option D, the injected code slips the database of the compromised server. Whenever you hear the word database, we're talking about SQL injection. So this option is wrong because it has nothing to do with cross-site scripting. It solely has to do with SQL injection. E, none of the above. F, all of the above. So going back to the question once more again, we're asked which of these is not a characteristic of stored cross-site scripting. So option A is wrong and option D is wrong. So the correct answer to this question is A and D. The injected code executes on the web server and the injected code slips the database of the compromised web server. Moving on to question number 10 and the last question for the day. Question number 10. The back-end request of an HTTP server can be exploited by the following except A, HTTP parameter pollution, B, HTTP splitting, C, HTTP smuggling, D, A and C, E, none of the above, F, all of the above. To be able to answer this question accurately, let's define the various parameters or options given. HTTP parameter pollution is a form of attack that allows the threat actor to manipulate or pollute the parameter of a web request, causing the server to process these requests in a confused state. So parameter pollution is when you inject a series of code and the web server tries to understand this code, right? It sees it in such a way that I don't really understand it, but I believe this parameter is fetching resources that I need to give to this user, right? So what the web server is like, in as much as I'm confused, I still need to push out any information regarding these resources that this user is requesting. HTTP splitting. This form of vulnerability occurs when an untrusted data are entered through a HTTP request, resulting the data being included in the response without properly validating the characters. Example of this occurrence is noticed in XSS-based attacks. HTTP smuggling is a vulnerability that exploits how the web server processes series of HTTP requests. This type of attack exploits the inconsistency in the request made by both the front end and back end server of the targeted web application, resulting in threat actors bypassing security controls and access to sensitive information. So as a web security expert, you should make sure you know much about these vulnerabilities. Going back to question number 10, we were asked all of the following except. So all three definitions given so far has to do with impact or negative impact on the web server hosting the various web applications. So the answer is option E, none of the above. So that summarizes the end of this week's Q&A series. It's very important we do this series because we believe even if we post these questions and put the various definitions, most of the things you've learned here today and we have described while we were explaining these various questions, you wouldn't have known about this. And this series is a way of, putting it out there, like having these emotional feelings whereby you feel like you're in a class learning and the teacher is telling you various things they know or impacting various knowledge they have regarding cybersecurity. And we hope subsequently we'll be improving this series, and we are finding a way to make this series in such a way each of the presentation would contain a detailed question. We'll see how it goes, but not this year. We'll continue this series till the end of this year, and subsequently we will know what we would do with regarding the Q&A series next year. But it's gonna be a lifetime thing. It's gonna be here, and we're not gonna stop it because we're excited to share whatever we know regarding cybersecurity, and all this is for free. So while you're watching this, please do not be stingy. Kidding. Do not be stingy anyway, and share with your friends who are still learning and passionate about cybersecurity. In such doing, we also grow in terms of our subscribers as well. It's very important. We believe this is a way we can generate revenues as the channel grows. We're still new and we have not yet have a lot of subscribers. So please, is it on forums? Is it on social media, Discord channels? Just subscribe. So moving on to the trophy for the week. If you had all 10 questions accurately, congratulations, you won the gold trophy. If you had 8 out of 10 questions accurately, congratulations, you won the silver trophy. And if you scored 7 out of 10 questions accurately, congratulations as well, you won the bronze medal. And for those who did not have any of the scoreboards, congratulations as well. You all matter. Everyone is a winner. Like we always say, cybersecurity, nobody knows it all. The most important thing in life is about trying and putting in your efforts, because effort matters a lot. Effort over time yields results. So we have finally come to an end of this week's episode, and we hope you have learned something new. If you find this video interesting, please do not hesitate to give us a like by tapping that thumbs up button. Subscribe by hitting that subscribe button, and turn on notification bell so that you'll be the first to get notified when we drop another episode of the Q&A series with Fixitgearware Security. Thanks for watching and see you next week. Bye for now.